Hello students, welcome to my channel Bhavya Physics. Today we are going to discuss about kinematic equations, that is motion in straight line, second chapter of first PUC physics. Before going ahead, if you are new to my channel, please do subscribe my channel and press bell icon to get the notification of all the videos. And if you like my videos, please share, like and comment your opinion. Now, we are going to discuss kinematic equations. What are these kinematic equations? So, there are the relation between velocity, initial velocity, final velocity, acceleration as well as time and displacement. So, the equation which connects all these physical quantities are called as kinematic equations. Okay. So, here there are three kinematic equations we are mainly studying. That is, one is V is equal to U plus AT, where V is a final velocity, U is a initial velocity, A is a uniform acceleration, T is a time, and X is a displacement. X is equal to UT plus half AT square, and V square is equal to U square plus 2AX. So now let us write the derivation of this. So arriving at this equation using graphical method is called as derivation. So how to arrive at this relation using graph? So for that you should know the basic definition of velocity, which is rate of change of displacement or rate of change of position. Okay, velocity is change in position with respect to time. Whenever the object starts to move, when the position of the object is changing with respect to time, and here the displacement means the object is changing its position in one particular direction, right? So distance and displacement, you should know the difference between these. So length of the path covered by body is called as distance, whereas displacement is object is moving in particular direction. So from initial point to final point, right? So the displacement is the shortest distance between initial and final point. So displacement is a vector quantity, means it has some direction, whereas distance is a scalar quantity, there is no direction. Whatever be the route you have selected to move from first point to second point. So here the distance is not depends on the direction through which you have moved to second point. So distance is a scalar quantity, means there is no direction, only it has magnitude. Okay. So distance by time is speed, whereas displacement by time gives velocity. That is the main difference between speed and velocity. And acceleration is rate of change of velocity. When you are accelerating the body, means its speed in velocity increases, or if you decelerate, its velocity decreases. So if there is a change in velocity, then body possesses acceleration, which can be calculated as rate of change in velocity. Okay. So slope of VT graph gives acceleration. We have studied VT graph. So slope of VT graph gives acceleration. That means acceleration is tan of theta, which is V by T. A is V by T. So slope of VT graph gives acceleration and slope of XT graph gives velocity. Similarly, area under VT graph gives displacement. Okay, hope you know all this. And using these points, now we are going to discuss this kinematic equation using graphical method. So here let us consider an object moving with initial velocity u, and in a time t it covers certain displacement x, and it is moving with final velocity v. By that time it has uniform acceleration a. Body is having uniform acceleration a. Then the graph VT graph looks like this. Here it has initial velocity, so O to A is the initial velocity. Velocity is taken along y-axis and time is taken along x-axis. So here I have considered some velocity. Okay, from here to here it has certain velocity, right? Initial velocity. If body is moving at rest, means the graph starts from the origin. Since it has initial velocity, it starts from certain point on the y-axis, and thereafterwards it is moving with increasing velocity or constant acceleration. Then graph is like this. AB is a straight line, which is a graph. Okay. Now let us, to find out this equation, let us join this point B to x-axis. That point is D, and join A to this line, so that is C. AC is parallel to OD. Now, see O to A is the initial velocity which is same as CD. O to A, CD, they are parallel, so which is initial velocity. And here the velocity is increasing. The point B is a final velocity. So point B is final velocity, that is B to D gives final velocity V. And since this velocity is U, means then what is this B to C? Remaining velocity, which is V minus U. Okay, and OD is equal to AC is T. Now let us assume that this angle is theta. Then how to write tan theta? Tan of theta gives slope. Tan theta is slope of VT graph. So what is the definition of tan theta? Opposite by adjacent. So here opposite side is BC, adjacent side is AC, and slope of VT graph gives acceleration. Therefore acceleration is BC, which is V minus U, and AC is T. So from this we can write AT is equal to V minus U, or we can write V is equal to U plus AT. This is our first equation. Okay, V minus U is AT, or if I write U this side, then V is equal to U plus AT. Let us call this as equation 1, this one. Okay, because we are using this equation for further derivation. Okay, next derivation. Now, so first equation is over. Is it clear? So here I have taken one concept, that is slope of VT graph gives acceleration. Using that I got this relation. Now the second concept is area under VT graph gives displacement. So displacement can be written as area under VT graph. So area under VT graph. Here you can see two structure or two shape. One is, you can see rectangle, another one is triangle. So first let us write area of rectangle OACD. Area of rectangle OACD plus area of triangle, that is ABC. Area of triangle ABC. So area of rectangle is length into breadth, that is OA into OD, plus area of triangle is half into base, that is AC into height BC. Okay. So for this x is equal to OA into OD, which can be written as, here you just refer this, U into T, and half into AC, A to C is T, T into B to C is V minus U. V minus U. Okay. So but V minus U is AT, therefore we can write, so from this relation UT plus half into T, V minus U can be written as AT. AT. Therefore, x is equal to UT plus half AT square. We got this relation. Okay. So, area under VT graph gives displacement. From that concept, we arrived at second equation. To get this third equation, now let us consider same concept, that is x displacement is area under VT graph. But here you can see two structure, so this together called as trapezium. So area of trapezium. So what is the area of trapezium? Area of trapezium can be written as half into sum of parallel sides. Sum of parallel sides. I'll write that parallel side. Which two sides are parallel? O to A, OA plus B to D, BD. These two are parallel sides. OA and BD are parallel sides. So sum of parallel sides into perpendicular distance between them. See, there are two parallel sides and this line is perpendicular. So this is OA and here BD are parallel and this line is AC is perpendicular. So therefore here let us write AC. That is, x can be written as x is equal to half into O to A is U plus B to D is V into AC. AC is T. Okay, AC is T. So here let us write this U plus V as V plus U, both are same. T is, from equation 1 you can write T as V minus U by A. So T can be written as V minus U by A. Now see, let us simplify it further. V plus U into V minus U is V square minus U square. right? V plus u into V minus u is V square minus u square divided by 2a. Cross multiplying, you can write V square minus u square is equal to 2ax, or V square is equal to u square plus 2ax. Like this, we arrived at equation 3. Okay. So, using this VT graph, we can get all these three equations. Okay. Arriving at this equation is called as derivation, and derive the kinematic equation is asked for 5 marks in PU board exam. So, they may ask, first is this one, x is ut plus half at square. For that, since this carries 5 marks, first thing is you have to draw this graph diagram that carries 1 mark, and arriving at this relation a is equal to, v is equal to u plus at, which carries 1 mark, 2 mark, and remaining is for this questions. Okay, if second one is asked, so you have to solve like this. Okay, 3 marks will be allotted for this, and if third one is asked, then you have to write like this. So for both you have to write graph first and arrive at equation 1. Okay, so graph and arrive at equation 1 is common for both. Okay, and depending on the questions you have to write properly, right? So if you have any confusion in this derivation, you comment in the comment section. I'll answer to that. And if you like my video, please like and share it with your friends, and please do subscribe my channel so that you'll get notification of all the videos, and you can see my all videos, right? Thanks for watching.